The big trick in neurofeedback is that we're moving the goalposts. So over the 30-minute run of the neurofeedback session, your brain's going to go through several normal to itself, typical endogenous, if you will, changes. It's going to runs of theta and beta and changes in speed and fatigue and stuff just happening. If we only pick out the 70 times that your brain had little 10-second runs of theta dropping and the beta climbing and just applauded those, of all the billions of things your brain is doing, your brain's going to notice, hey, wait a minute, why is my theta going down being applauded? Okay. And it's going to start chasing the information flow as we ask it to have to do even more to get the same gameplay. We move the goalposts adaptively. And then 10 minutes in, 50 minutes in, your brain's a little tired and you're actually not able to make the same, you aren't fluctuating as well in that direction anymore. So we make it easier. We move the goalposts, the thresholds next to where you are. So when you fluctuate again in the right direction, the applause resumes. So we're giving a directed signal of movement. And when you have these 2 or 3 different brain waves, you might be training in a session. You might be training down some slow brain waves, training down some very fast brain waves, and training up some in the middle. So you simply measure the amount you're making, boom, 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 and put a threshold just above or just below where somebody is.
Collective Insights is a voyage through topics and technologies revolutionizing human well-being. Groundbreaking approaches for a better world and a better life await you. Welcome to Collective Insights.
This is James Schmachtenberger, CEO and co-founder of Qualia. I appreciate your support of our podcast, Collective Insights, and I encourage you to try the formula that launched our company, Qualia Mind. Qualia Mind promotes life-changing enhancements to your focus, energy, and overall mental wellness. This podcast interviews world-renowned experts on crucial aspects of mental wellness, such as sleep, exercise, and mindset training. But if you also want to add the life-changing brain nourishment to your diet, try Qualia Mind at neurohacker.com. You can use code JAMES for an extra 15% off. That's Qualia Mind with code JAMES at neurohacker.com, and I hope you enjoy today's episode.
Welcome to today's podcast episode. I'm Lauren Alexander, and I'm absolutely thrilled to introduce our host and today's discussion. Even though we may not have crossed paths before, I have been working tirelessly behind the scenes, working on each and every episode of Collective Insights. We have covered neurofeedback with Dr. Andrew Hill a few times on Collective Insights, but we've never really had the time to dig in deep to the mechanisms and science behind it. So today we aim to deliver a really comprehensive exploration of how brainwaves work, and to our advantage and sometimes to our disadvantage, and perhaps killing some myths and sacred cows about brainwave beliefs that are floating out there. I'm here, and it was really because of the episode on neurofeedback that we did now nearly 7 years ago with Dr. Andrew Hill that led me to explore neurofeedback for myself. And as of this morning, I have done over 70 neurofeedback sessions, and it has literally changed my life. And I think that you're going to really enjoy this episode. So buckle in. If you haven't met him before, Dr. Greg Kelly is going to be our host today. He is Director of Product Development at Neurohacker Collective. He's a naturopathic physician and author of the book Shapeshift. And as I mentioned before, Dr. Andrew Hill is here with us. He is the founder of Peak Brain Institute and a top peak performance coach in the country. He holds a Ph.D. in cognitive neuroscience from UCLA's Department of Psychology and continues to spearhead cognitive research using EEG, qEEG, and ERP methodologies. He has been practicing neurofeedback since 2003. Andrew, welcome back to the show. And Greg, go ahead and kick things off.
Sure. We've got a lot to cover. And one of the things we really wanted to dig in deep here was about the different brain waves that our brain's making all the time, mixing together to perform in different ways. So can we start just maybe a quick background on what brain waves are? Andrew?
Sure. So thanks for having me back, guys. Nice to see you both. Brain waves are oscillations, little rhythms the brain is making. The cortex, more specifically, the brain has a bark, a layer that's got wrinkles, gyri, and cell side bumps and grooves. And the parts of the cortex that are sort of oriented perpendicular to the scalp, to the skull, you're actually getting the ability to read the brain through that part of the scalp. So we have something called microcolumns, also occasionally called mini columns. One is electricity, one is size. And it's something like 30,000 neurons in a column, a little like block party in the city, one building. And that whole block party is jam into the same little rhythm and then firing, if you will, at the same rate, the same, dance pattern. And you might have 30,000 neurons and a couple 100,000 glial cells, the support cells, all kind of making up this little one machinery. And we have billions of these things. These are all the CPUs, and they're 6-layered block buildings, and they have some clotheslines going to the local buildings next door, sending back messages, and they have some long distance communication with pigeons to further buildings away, and they all influence each other's local neighborhood sound and intercity communication, called microcolumns or mini columns. And how fast they're bouncing is a brainwave. So the brainwaves are named things off the Greek alphabet. And the first one, alpha, isn't the slowest brainwave. It's just the first one we measured, basically. It's a very easy brainwave to see. And we measured it before we had like modern electricity even. A scientist was bouncing light off of reflections of an exposed cortex and saw a ripple in the of a flame candle on a wall with an interference pattern, and realized it was a brainwave being evoked. So they're really these subtle phenomena that we've known about for years, but we've never really deeply understood. We still don't. But alpha is about a 10 hertz, a 10 cycle per second wave. And it's sort of like the idling mode, the rest mode, the bass, the background. And it really represents the index frequency, the basic speed of your brain, the speed at which you idle. And it gets faster as you get older, as you myelinate the brain, as you produce more cells, it gets faster and faster and faster, and your speed of processing climbs. And then as you get quite older, you start to lose cell density, lose myelination, and your speed of processing dips. That's when word finding issues start showing up. That's the alpha speed dipping, for instance. Or maybe you got COVID or a head injury or haven't been sleeping for 4 or 5 days or 6 weeks, and then you have brain fog, same phenomena. Alpha is draggy, so you can sort of feel this, you can feel your alpha speed if you're having handoff or information flow issues, essentially. So alpha was the first brainwave we thought about. It was the first one that we kind of got into in the field of neurofeedback or biofeedback back in the 50s and 60s. It's not necessarily the most exciting one to exercise. It's just really obvious to sort of measure. And starting at sort of the slowest brain waves, if you will, we want to talk about delta. And delta happens up to about twice per second, 2 hertz. And it's the heartbeat of the brain. It's the background of your metabolism, the sort of brainstem phenomena of keeping your heart and lungs moving, and all the involuntary cell metabolism stuff. And bursts of it dominate in slow wave sleep. That's a delta sleep phenomena. It's very non-conscious background processes of the brain. You don't think in it, you kind of live in it, basically. And you'll see that the brain will produce general amounts of it. It'll fill your delta bucket at night. It'll kind of recede in the background during the day for most of us. But if you're sleep deprived, it starts to climb up in speed and get rushy and push around. And you see there are high amounts of it because your brain's sleeping when you're awake, or it's very fast because your brain's rushing around trying to heal you or sleep you when you're awake. So you can still get hints of this delta reserve not being well managed, even though it is still fluctuating and doing the basic things. Delta is slow. As you go in faster speeds, you get to theta and then alpha. So in between the alpha neutral and the delta rest and repair mode, you have the theta, and theta is the release. It lets things happen. It takes the brakes off. The cortex, these billions of little microcolumns, are organized in modular neighborhoods that do specific things. Sometimes all of the time, primary cortex doing something. And sometimes it creates temporary networks, association cortices, frontal lobe, parietal lobe, and makes meaning of other people's information, mostly other neighborhoods. So as these circuits are all bouncing around, the delta is an inactive resting mode in the tissue or the whole system. Theta lubricates, it releases the little block party to happen, or a normal behavior of a circuit to turn on or happen automatically. So you need theta. Theta is 4 to 7 hertz, basically, roughly. And around 6.5 hertz, a burst of that is the moment of insight, the aha, the sudden memory of the thing you didn't think you actually knew. That's 6.5 hertz. You need that. But if you make large amounts of 4 to 7 theta broadly throughout the head, then your modules are kind of automatic and stimulus driven, and you have poor inhibitory tone. And we call that ADHD. Squirrel is a high theta state. We can't inhibit. You see all the patterns, the novelty, the stimulus, the outside world will drive you and put you in a mode. But in the absence of that ability to load up your modules and make them, engage in their automatic way, then it's harder to control yourself, to inhibit, to direct the machine and decide how that information is rising off of that part of the brain. So delta, theta, alpha, and then you're into beta. And beta is a pretty wide range. It goes from about 12 hertz all the way up to about close to 40. And 40 is where something called gamma starts. And beta is pretty great. It's the modular activation, the gas pedals, the gears, the voluntary, and you think in it, you perceive in it, you have emotions in it. That's most of you that you're aware of as a thing happening in beta. And the default mode network runs in beta, and specific sensory tissue uses beta, and language tissue kicks off in beta. So mostly you're aware of just that surface and just that, faster brainwave set to some extent in terms of the mental, cognitive, higher human self stuff. It's up there. But there's a special frequency within beta, and it's in the lowest range. It's in 12 to 15 hertz, and it's called the sensory motor rhythm. And it's what a lot of the field of neurofeedback is centered around, or was discovered to sort of, that's the big lifter. You can kind of think of that beta wave, that sensory motor wave, as the relaxation mode or the idle mode or the rest mode, just like alpha, but in the motor range, in the movement, in the control, in the thought range. So SMR beta, low beta, when it occurs on the strip of tissue that goes from ear to ear, we have the sensory tissue and the motor tissue there, just in front of and just behind the central division. You have ascending information rising up from your body, registering just behind the central sulcus. And you have descending motor control and voluntary control going down and just in front of the central sulcus. And this little bit of tissue, when you're relaxed, when you're sitting still, when you have self-control and you're not distracted, you're making lots of SMR, lots of sensory motor rhythm, the strong inhibitory tone. And those of you who are wondering in the abstract what this might feel like, well, you've probably seen it. If you have a cat who lies on a windowsill and becomes very still, watches the bird, that laser-like focus and physical inhibition, that motoric stillness, that's a high SMR state. That's literally the opposite of ADHD, like literally. SMR and theta in inverse relationship is a thing you can screen kids for and go, oh, impulsivity. Okay, classic. Nice. You're one of those. So delta, theta into the betas, and then you're up to gamma. So gamma is kind of, for those classic literature people, it's a snark. It's a boojum. You're darting at shadows if you're concerned about gamma in a biohacker context. It's kind of like the word quantum. You got to be really careful in a biohacker context if someone's using the word quantum. Most of the time, they have no idea what they're talking about. Some of the time, they're dishonest. It's a big problem. Unless you're getting nuclear medicine, you probably shouldn't be using that word with regards to your health. Honestly, it's just not valid. Sorry, I'm very opinionated. That's what the podcast is for, apparently. But functionally, gamma is a thing. It exists. We know about it. We've measured it. Cliff Sarin, B. Alan Watts did a bunch of work at the Samatha Project showing you gamma coherence changes, connectivity changes in long-term meditators that are amazing. You see gamma changes in schizophrenia that are quite altered. You see it in aging that are altered, but it's really, really hard to measure gamma waves, 40 hertz waves. There's something called the 1/F rule, the amplitude over frequency rule, in all living systems, actually all systems that are dynamic and stable, that oscillate, like weather or your body. Oscillations happen, and if they're big oscillations, they have a lot of energy and they're slow. Delta waves, big delta wave. If you have 10 microvolts of delta, you got one or two of them. But when you go up to gamma, 40 hertz waves, you get tons of little tiny gamma waves for the same energy to produce one, let's say, delta wave. And that means as you go up in speed, you go down in the size of the wave, down in amplitude. The problem with that in EEG is waves, as they travel from the brain through the layers of the meninges, the tissue, the skull, the scalp, they attenuate. Each of those things is a filter, and it drops the amplitude of the waves, and it drops some of the fast waves so much that you cannot measure gamma through the noise floor of EEG without getting under the skull, or without using hundreds of thousands of dollars of very expensive amplified equipment. I've done some of that work. You can do it, but if you haven't spent 100 grand on your EEG rig, you probably aren't really measuring gamma. And most of the literature for the first 50 years in gamma has been retracted because most of the researchers discovered they were picking up eye saccades, the movement of eyes, the vibration is in that muscle range that then tends to bleed into frontal electrodes. So gamma is a bit of a thing with that. It's interesting, but you need very specialized equipment that's either designed to sort of just measure that, or it's very expensive, broad amplified equipment at the scalp. So it's hard to do with passive consumer or prosumer or even decent lab grade gear reliably. But one of my mentors in this space, a guy named Jack Johnstone, who passed on a couple of years ago, helped a company develop an algorithm for measuring consciousness using the ratio of gamma to theta. So gamma is about 40, theta is about 4. Turns out these suckers nest, they ring together, they synchronize. And the angle, the phase, the synchrony between this ringing is how conscious you are. And if you break that timing, you create unconsciousness. So all the major anesthetic drugs that knock you out do so by changing, we think by changing the microtubules that change how some of the ions work in your neurons. But the functional effect is you change the phase angle, the coupling of gamma and theta. You get consciousness change, and you can kind of measure. There's the bispectral index, the BIS. It's a commercial product, is a amplified single electrode you wear on your forehead in many hospitals in the US now during surgery. So the anesthesiologist can look at a numerical scale of how conscious you are and use that to gauge consciousness. And this is why gamma is so sexy, because it has this consciousness thing in a valid way, not in a way that gets you drummed out of your grad program by using the word consciousness. So people get excited about it, but it's really hard to measure, and it's really noisy, and it's really hard to get in a modern, even modern technology. You're just not really generally doing stuff with it. And yet people who train it with neurofeedback there's a whole category of biohackers who use neurofeedback. A lot of them have gotten into something called the tag sync, theta, alpha, gamma synchrony training. And they're reporting amazing subjective effects, flow states and transformation. But I'm fairly certain that what they're doing is simply manipulating theta and alpha. And there's a category in neurofeedback called alpha theta, where you do creativity, flow state, relaxation work, immune work, substance craving work. It's fairly powerful protocol of neurofeedback. And I believe you're getting gamma effects. You're feeling consciousness changes, but you can do it by manipulating your theta. And meditation creates theta changes that are measurable. So I would say it's you're at risk of elaborating in the space without actually using the tools that are right there to go after, that are a little more understandable, and then you can worry about things below gamma. But that's the landscape. From about 0 to about 40, gamma goes from 40 up to about maybe 1,000 actually, but we can't really measure it. Cliff Sarin and Beyond Watts did some work again with the Samatha project. I think they showed changes in gamma phenomena at 200, at 400 hertz, really, really fast brain waves. But that, again, it's a very hard phenomena to get access to without being under the skull. So it's your brainwave primer.
Well, one of the things I just want to make sure we point out to the audience, a benefit of qEEG is it's basically taking the EEG, right, the electrical activity of the brain, but then mathematically slicing and dicing it so that you understand, like, okay, there's this proportion of alpha in this part of the brain, and it's got this amount of delta. And then when you talk about something like the alpha theta training, you're actually saying, okay, well, when we look at your resting state or eyes open, what we're seeing is, this brainwave looks like a weak muscle. It's not doing its fair share. Let's teach the brain how to strengthen that and do more of that. Is that something along those lines correct?
It is. The only subtle inflection I might want to add here is that while the performance testing we do alongside the brain map is graded, it's good or bad, and here's some deficits, here's some performance, brain maps are really not showing what's weak or strong, just what's weird. People are weird. So we start off, okay, how unusual are you for the average person your age on a bell curve and some heat maps? Okay, wow, your alpha is really unusual. Oh, your theta's doing that. Wow, your beta's interesting. And I don't know what that means for you. I just know now it's plausible, what's often true, what could be true, what is visibly potentially showing up, but it's not you. It isn't the subtlety of you. It isn't the experience broadly. but it might represent the stuff that shows up most reliably, the stuff you can usually spot, are the regulatory features that all brains engage in all the time. The executive function, the features of impulsivity or inattention. You can see things like speed of processing, which is, again, that alpha speed, and that will represent experiences of like word finding issues and delayed recall. That's a laggy alpha speed, for instance. You can see almost all the flavors of anxiety in a brain map, as far as I can tell. Not so much developmental things that are slow moving and that are gradual, but almost all of the flavors of acute or low key anxiety, perseveration, rumination, sensory and social irritability, strong trauma response stuff, are things that show up as signatures in specific tissues that are cramped up. If your anterior cingulate's cramped up, well, you're either a high-powered CEO, you got a little bit of OCD, maybe both. Let's talk about your anterior cingulate. Oh, your superpower is steel trap mind, huh? Does that get stuck? Oh, it does. Okay, you want to work on that? All right, let's stretch that out. It's a relationship with your physiology. It's not so much about which label we get to. So, you see stress response things, executive function things, speed of processing, brain fog, sensory and social when it's really unusual. Those are the big features. And from there, we should probably ask Lauren, who's gone through it quite deeply. I do not remember a few months ago when I went over your brain map the first time, because we've done a lot of mapping. Part of our job at Peak is to teach you to become your own expert. So you dove into that a little bit, but what did we find? What was your experience the first time, perhaps, of looking at your data? If I could put you on the spot for a second.
Yeah. I think one of the really meaningful things for me is I entered and was curious about the training just as like a biohack. I didn't come to the table of like, I want to address anxiety, I want to address depression, I really was like, I'm a biohacker. This is the next cool thing. And I really had no idea until having some of the, brainwaves speed up and catch up, that I was really carrying this like 50-pound bag of anxiety around. And so when that bag was taken off, that's when I really had my eyes open. So in the maps, when you went over things with me and saw, there's a cluster over here, does this ring true to you or not? I was like, yeah, kind of. But the whole experience to me and the training of it has really kind of opened my eyes to how, a year ago, I was such an anxious person, but I wouldn't have labeled myself as that. And so it's been really amazing. And it's kind of crazy that such a simple thing of training, of exercising your brain in a targeted way, exercising. And I'd love to talk about or ask about, you have these sessions, and they're very specific, like CZA1. And this is the frequency that we're going to inhibit. This is the frequency we're going to reward. And what does that really mean? Like I know I'd love you to unpack some of that so that we could really understand altogether what's going on during a neurofeedback session.
Sure. There's a couple different ways you can do neurofeedback. A pretty classic way, the way that we do it, is using passive reinforcement learning, operant conditioning. I'll unpack those terms. But we often measure three different brainwaves, three different sets of frequencies at one location, or maybe more than one. We occasionally do like lots of wires, but usually 1 or 2 wires in the head, measuring your brain at specific places you might want to exercise. Broadly, executive function stuff's pretty straightforward. The left side of the brain, kind of on that sensory motor cortex, its job to some extent is to keep the spotlight bright and stable and clear and on things, even if they're boring. Keeps you awake when you're awake and on, and it also helps keep you asleep at night, which is kind of cool. So it's this mode maintainer. The right-hand side helps with pumping the brakes and not going squirrel, with that SMR theta ratio thing, the supervisor of your attention. Are you appropriately paying attention, or are you allowed to react to the new stimuli? That's the right-hand side more for most of us. And both of these tissues do their job, do their supervisory control thing with beta of some sort. And they both kind of become more automatic with thetas and alphas, the slower brain waves. So pretty classic way to train your brain might be to do 50 minutes of one and 50 minutes of another. And we're going to want to bring up some beta on the left side for a few minutes while bringing down some theta, maybe. And then 15 minutes, move the wire, bring up some beta on the right-hand side and bring down some theta. And when I say bring up or bring down, we're literally just exercising by watching what the brain is already doing and then providing contingent feedback. We're only applauding some of the stuff the brain is doing. So if you stick some wires there and put some ear clips on and measure the amount of beta moment to moment you're making and your theta, whenever your brain happens to make briefly a little more of that SMR beta and a little bit less of the theta, the computer sees that and goes, oh, good job, brain. And a game starts to run on the screen. Your Pac-Man needs some dots. Your puzzle pieces fill in. What's your favorite game, Lauren?
Horses. The horses pictures.
You have a picture gallery? Yeah, we have
Yeah.
this game we use called Formation where you can load in beautiful pictures and art, and it's like a picture grid that unveils and shows you more and more. So for every 1 second or so that your brain for half that time has spent with your theta going down or staying down and your beta going up or staying up, the computer goes beep and shows you a little bit more of a picture. So it's unveiling it as an applause stream. Good job, good job, good job, good job. And then your brain moves in the wrong direction. The game stops for a second, and the brain goes, "Oh, wait, where's my information? Where's the applause? Why am I not getting stuff happening? I kind of like stuff. Stuff's cool. No stuff isn't so cool. Where's my stuff?" And then it happens to move in the right direction, and the applause resumes, and the brain notices it. The mind doesn't actually notice it that well. Usually 3 or 4 sessions in. When did you notice it? Because you're a biohacker. People are subtle. And
I based on, I've asked a lot of people what was normal, but I think I'm like a super responder because after my 3rd session, I felt completely different. And it's built and it's over time. I mean, I've done a lot because, it's like once you get a taste of this, you want more.
So 3 sessions, 4 sessions, 5 sessions, that's actually pretty typical to feel something. I think you did get I remember you got a pretty strong, specific response. Sometimes the things we start with are the things you really need, and you get a really good response right away. I think, that was you. But the mind doesn't actually notice the process happening right away. The brain does. They gave me a Ph.D. at UCLA for demonstrating that learning loop of neurofeedback. I think I did the first double-blind, placebo-controlled study on neurofeedback, and I did it looking at that game, that formation game, how the brain reacted when the reward popped up, the audio beep and the picture reveal. I grabbed that event in ongoing EEG, and then you snip out those EEGs, you average it together, and you lose all the endogenous background information. You're left with the learning event called an evoked potential. And you can look and see how that evolves in response to the brainwave you're applauding. So I demonstrated that learning loop, the brain starts to go, oh, beta waves? Cool, beta waves. Within about 5 or 10 minutes for everyone, the very first time you do neurofeedback, the brain's going, whoa, hey, why am I reacting to beta? Beta's cool. And the mind has no idea typically. And then a few sessions and you're like, hey, wait a minute. I might be feeling a little different. It's interesting. Or maybe more in your case, but it's this passive, involuntary operant conditioning. The big trick of neurofeedback is, well, are you getting the effects you're looking for or not? This is changing your brain briefly, gently. It's not permanent right away, but you're pushing on your brain. We want to make sure we move in the right direction and not just how we assume you are built from some assessments or from some labels you've been given. So we work really carefully to move from sort of a scientific modeling, here's some ideas about you, what's important, let's understand you, yay, brains, into more of a, let's be careful, let's listen to what she's saying. Are we moving towards your goals? Are there shifts? Is there new suffering we can try to support? Are there new transformations she's looking for? And we learn your experience day to day by asking you sleep, stress, attention stuff. And as that starts to fluctuate, we're sprinkling in little workouts, trying to elicit effects that are in the direction you want to go in, and then doubling down when you say, oh, wow, hey, wait, I like that one. Oh, okay, let's give her 2 more of those. I think that's a good one for her. Great. And the coaches stay on top of you and help, celebrate the wins and commiserate when things are stressful. And that means you don't have to worry about how to do neurofeedback. You can just worry about, am I noticing anything from this stuff? Or should I be a squeaky wheel and ask for more? Should ask for more. But it becomes very much like personal training where you get to validate the workout, be annoyed at your coach if you're too fatigued, ask for a harder workout, and start to learn how the system responds over time. That's the neurofeedback, or the intervention itself. And then, of course, we map the brain again, and we get to go back and be scientists and say, is it plausible you're feeling different in this way, and teach you more. The field of neurofeedback was discovered because somebody was manipulating SMR, and you got an anti-seizure or seizure protection effect from it months later in animals back in the 60s. Dr. Barry Sturm at UCLA was testing methylhydrazine, rocket fuel, on cats for danger levels, basically. And some of the cats refused to have any instability events in the brain. Oh, wait a minute. These cats were used 6 months before. And since cats make so much SMR, he just squirted chicken broth into their mouth whenever they made a little bit more and shaped it. Okay, cool. You can operantly condition beautiful. These cats became super cats, seizure resistant. And his lab manager was epileptic and uncontrolled in all of her meds, having tens of seizures. So they built her an auditory reward to SMR, and her seizures dropped away, and she went off all of her meds. That was the start of the field. But here's another thing. SMR is also called sleep spindles. It's the thing that keeps you asleep and causes memory consolidation to kick off. So when a dog barks 3 houses away and you know that dog, you don't wake up in a threat. You just suppress the wakeful rouse moment, and the sleep spindle kicks in, and you have this, deepening of your sleep. And then that kicks off a 9-hertz spindle in the hippocampus, which causes that memory consolidation stuff to start to move short-term memory to long-term memory throughout the cortex. So it's this motoric inhibition that allows that deep rest, that deep staging of architecture. And it's unusual to get deep sleep improvements with alpha theta training, because that actually, alpha theta, to some extent, brings you into the hypnagogic mode between awake and asleep. And it brings up the theta, the nonlinear, the insight I mentioned earlier, while dropping the aware idle, the alpha, so that you're actually in more of a theta dominant state, more creative, more shifting. It's that state people know because they have good ideas before they fall asleep, or remember that thing before they fall asleep. That's a theta. It's a hypnagogic access state, a nonlinear state. It's a bit of a flow state access for many of us. While alpha theta neurofeedback brings you right to the edge of that and holds you there, just holds you there. So you end up getting that deep relaxation, but you also, many of us, get insight in alpha theta. Stuff bubbles up. We start to feel our feelings and know how we feel them. I get calls from the spouses of high-level CEOs. Oh, whatever you just did, do that again. He brought me flowers. We had the best therapy session. Oh my gosh. And people say things like, oh my gosh, I was so eloquent in that fight. I wasn't mean to my wife. Oh my goodness. And artists and creatives get back in the zone and can find their flow again. So alpha theta is pretty amazing. And it was used in the 60s and 70s a lot in something called the Peniston protocol for alcohol, for substance use disorders, specifically with alcohol a lot. And it seems to reverse, in the literature, reverse the 1-year relapse rate with alcohol from 75% across all interventions to 25% when neurofeedback is added. Similar kinds of impact alpha theta used for violent offenders in Canada. Doug Cork did a bunch of work on this. Same kind of thing. The 1-year reincarceration rate for violent offenders dropped from 75% down to 25% in a study when neurofeedback was added. So it gives you that in-between state, that emotional access state. It can irrigate some release for some stuff you aren't aware of. It can do gentle sideways, careful work in trauma for some of us. And you apparently got a healing response from it. I've seen it jack up T cells to 15, like really take CD4 plus cells and bring them way, way up. And this is a known effect of alpha training in general. Alpha speed training back there brings up T cells. Dr. Gary Schumer in Orange County did some work on that. But alpha theta, the next door neighbor of alpha training, seems to also release such a deep healing, a deep relaxation response, that there's a surge of growth and healing. And I think your deep sleep was a secondary effect. It was the consequence of that incredible release of growth hormone and T cells and relaxation. Your brain's like, oh, we're going to do 3 hours of deep sleep tonight to do some cleanup and restock the shelves, because, oh my God, yes. But we didn't provoke the deep sleep necessarily. If you had a chronic generalized anxiety disorder and I trained your beta, we would produce less anxiety and better sleep maintenance. And that's about sleep architecture specifically. Now you're training the actual sleep system, but you can go after either way. Great. Oh, she's getting great sleep. Cool. Wasn't a primary goal. Glad that's happening. That suggests we're on track for her brain, because you train the brain and it flexes. You go to the gym for your abs and your shoulder hurts the next day because the seat height was set wrong or something. So in neurofeedback, you train whatever your attachment trauma, your creativity, your flow state, your laser-like focus, your seizures, and you get a little flex over the next 24 hours on sleep, stress, on attention, on speed. And by noticing those things, you index the protocol, the exercises you're doing. And that's what our coaches are doing for you, Lauren. They're saying, hey, haven't seen a sleep survey in 3 days. How you doing? Just gonna do some planning for you. Is because they want to see if you're noticing those fluctuating things we can use to index the path you're on and help, create a bit more of a tight coupling to where you want to go. So it's how you change your brain.
I'm not sure if this would be an appropriate analogy for qEEG and neurofeedback, but sometimes I'll hear a descriptor like top-down brain, bottom-up, right? Like the top-down is like the predictive brain, right? What's filtering out a lot of experience and saying, okay, well, I know this person's going to insult me, so whatever they said, I'm going to feel insulted. Where, that bottom-up is more like the raw sensory input and the raw, emotional thing. And that it would sound like to me a lot of what this alpha theta training does, it's allowing more of that raw to like bubble up and now cause that top down brain to say, oh, my prediction might have been incorrect, let me update that.
I think you're right. I think especially in things that there's a syndrome called alexithymia, which is inability to talk about how you feel. I mean, some people believe all men have this, but I don't. So you can reliably get access to putting your emotions into words using alpha theta for most people, and it works counter to that phenomena essentially. I think it's exactly what you're doing, Dr. Kelly, is educating the more frontal, the more top down about the more visceral, the more back. In fact, alpha theta neurofeedback is done on the back of the head. Hey, pro tip: in the brain, front of the brain, inside self; back of the brain, outside world. So the deep awareness stuff you're doing is actually on tissue that's used to integrating the outside world into the self. It's not on the highest level cognitive stuff and the most decision-y and thinky stuff and the holding stuff and the attention stuff. It's in the making meaning of things that as they come in. That's the places you're doing flow state work. So, yeah.
And one of the things you mentioned earlier was the default mode network, which I just think of as the me network. But I would, that obviously has a lot to do with the stories about our past, rumination. Sometimes they'll say time traveling, right? Going into the future to be anxious about it, the past to be worried or depressed about it. So I would imagine a lot of this neurofeedback training must be making some fairly dramatic changes in the default mode network, and maybe the attention network. You've mentioned executive function, but there's an executive control network. And I would think these are all just like, you could almost see these connections in qEEG.
And you can see the networks, the rich clubs, the rich hubs. You can see the salience network, the executive network, and the DMN default mode network all kind of show up. Like the front midline and back midline are big clusters of tissue called the cingulates, and the anterior cingulates, which is what you're thinking about or planning for future. And the back midline, posterior cingulate, does watch the road, heads up, and evaluates the possibility of things having gone wrong in the past. So the outside world and history. So yeah, if your posterior cingulate's lit up to, a couple standard deviations above average and beta waves, I'm going to think you're either a lifeguard or there's some threat, activated sensitivity and you're ruminating all the time. Maybe both, maybe neither. Maybe you're just weird. Good job. Be weird. But let's talk about the fact that, hey, this posterior cingulate, this often cramps up when the world isn't especially safe or predictable. Are you kind of like threat sensitive and activated? Kind of visceral? You are. Do you care? You care. All right. We don't know if it's true. Who cares what we call it? But if that matters to you, want to stretch that? See how it feels? Okay, cool. So you can take pretty severe threat sensitivity, trauma response, PTSD type phenomena, and you're not doing anything invalid, but you're framing this as physiology, as mechanistic, and saying, wow, the suffering, that really is important. That really matters, but it's just your brain. So A, people have a sense of agency with things like neurofeedback, but B, understanding how it works means you can be frustrated and it hurts, but you have a much harder time being ashamed about it or being overwhelmed about it when you have that sense of like, oh, wow, my back midline is doing this lifeguard thing. Oh, okay. Huh. Great. Now you know. So you can see the DMN, anterior cingulate, posterior cingulate. Behind the right ear is the tempoparietal junction. I call it the princess and the P. It maps the world into the self. So if someone's voice is irritating or they're chewing too loud and destroying your concentration, or You find everyone's face is too loud and their voice is too annoying and all that stuff. That's the back midline, the back right behind the ear. But of course, they're not separate. Like the cingulates are sort of at the intersection of the networks involved with the self, the racetrack of the internal reverie and awareness. That's the true DMN, and the executive areas, the left stabilizer focus, the right inhibitor of distractibility. Those will be directly tied into the cingulates. And having those different networks, those rich clubs and hubs locked up together, start to predict some of the phenomena you see. And I have a very different perspective on the brain after doing the physiological stuff than I used to after working deeply in psychology for many, many years. For instance, there's the default mode network in the front, the anterior cingulate, and that back right, the TPJ, the temporoparietal junction there, will co-activate, co-lock up when you are obsessively focused on things in the environment that are irritating. And so you see this in something called misophonia, when a spouse is about to kill their husband because he's chewing too loud. That actually happens. It's like an OCD tic, rage from small sounds, mouth sounds especially, because they're weird. So you see this like obsessive type of thing, but that same coactivation, right TPJ and front midline, you see locked up in claustrophobia and in agoraphobia. You would think they would be somehow like opposite. No, they're about the mind being obsessed about the environment being uncomfortable. Oh, okay. And they have an outside world map to the self kind of relationship safety. Oh, so I helped somebody with agoraphobia a couple of years ago, 2 summers ago. She did a remote program, and after doing 8 weeks or something with us, went on a road trip to a wedding and came back from it with pictures and success stories and posted them into her Facebook group for agoraphobia. And I got 12 people the next week who had agoraphobia who got maps, and 9 of them had this pattern. I went, oh, agoraphobia looks like other tic disorders. Holy cow. It looks like claustrophobia. It looks like misophonia. It looks like Tourette's. Huh. And then you talk to them about their DMN and their anterior cingulate and the TPJ, and you start to decompose this from the big scary label. Hey, here's how you might in this anterior cingulate also means that you have a mind like a steel trap. And the right TPJ also means that you got all the feels and you got all the empathy and you're a little raw, but it's kind of a superpower, huh? Okay. And it's not about this monolithic application of label or identity at that point. It's more about, okay, here's how it works. And I'm able to do something about that and stretch that tissue. So, it's my soapbox.
Well, and I think and I just want to illustrate this point. I think I often tell Lauren, I think of feedback as the breakfast of champions, right? And creating good feedback loops should be our goal in as many areas of our lives as possible. And like one, I would say, example from my way distant past, back in, I think it was 1990, I decided to study Thai language. And one of the first things we did was learn colors. So in English, that NG sound that you'd have at the end of a syllable, like ring or wing, like we've got that, right? We heard that sound in that location at the end of a syllable. In infancy, our brain, wired to hear and say that appropriately. But Thai, Vietnamese, they have that sound at the beginning of a syllable. We simply do not, right? So the word for blue in Thai starts with that NG sound. And I can remember my professors, holding up something blue, having me say that, shaking his head over and over again, right? Because my brain just couldn't tell what he was saying and what I was saying, how those were different, right? And there was no feedback loop to correct it. My brain didn't have that sound feedback loop. And what I really needed was someone to create that, almost what neurofeedback, like ding, 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 you said it right this time, like more of that, right? So I think
you also need to hear the difference.
Yeah.
Right. The ages 9, 10, roughly, the laterality left-right division finishes off. And at that point, the brain prunes out the possibility of hearing new speech sounds. Because if you hear something that's kind of like a phoneme you already know, it's probably the guy from the village next door. It's probably not a new language. So this is the basis of both our accents, that if we learn languages after age 10 or 11 or 12, but also the inability to hear speech sounds that aren't fully, nuanced in our native tongues, unfortunately. So.
Well, and I guess to finish off my analogy, I didn't need to be told I was doing it wrong. I knew I was doing it wrong. I needed help doing it right. And to me, when, I think of what you offer with neurofeedback, it's teaching the brain how to do things right that before it was just stuck. Hadn't figured out that on its own. The chances are that it would figure out on its own are fairly low, where if it could have, it probably would have. And it's why, you see so many miraculous things with the brain in such a wide context of limitations. And like you said, some limitations, maybe a superpower in another area. So let's keep that, but let's, like help you overcome the limitation.
And you can measure things you can't feel. So you can train involuntary aspects. I mean, you can do things with neurofeedback, you can do with meditation, but that's only the voluntary stuff. You have a really hard time accessing tissue you can't literally feel with meditation, but you can go right after it, measure it in real time with neurofeedback. So it gives you like an end run around the voluntary and the mental, but you also do get the benefit of the imposed feedback loop of talking to your coaches day to day about how you're feeling and monitoring your sleep. And, Drucker, what is measured is managed here. And if you start recording your sleep and recording your energy level and your mood and your stress, because you've told us those are your goals and we're having you let us know if they iterate, well, you're going to be really aware of what your mood is doing day to day, your sleep habits are doing. If you're actually taking, oh my gosh, I got to tell peak brain coaches that I am my Aura ring shaming me again. Oh, wow. That might mean you don't eat before bed tomorrow, because you have the reflective coaching piece of it. And it means that you start to notice and shape. And as an aside, one of the best ways to track your sleep in the literature, among the most accurate, is tracking your sleep, is rating it subjectively. And if you do that routinely over time, you become as good a rater as the best combination of EEG and actigraphy and everything else. You actually approach perfect if you just start doing it eventually. And it actually gets better than most of our biohacker sleep trackers we have access to. You can get there pretty well. So the point is, observe, record, make notes, be mindful. Don't let momentum push your brain, your circadian rhythm, your sleep habits, your food, your stress response around. Start looking at those systems and thinking about how they move and starting to steer them. So we try to sneak that in while we're training your EEG. We try to teach about circadian stuff and the best way to do keto if that's your jam, or whatever other biohack you're layering in. We try to give you a little bit of best practices so that you have this longer term feedback process built in to steer changes for yourself. So,
well, Lauren, you've been, listening attentively. Are there any things that may have come up that you have questions on, or think our audience may benefit from some clarification?
I think we covered the brainwave piece really well. But one thing, at least that I really appreciate about neurofeedback on my, understanding of it, is about how it's about pattern recognition, and then how the brain is just this pattern recognition engine in it of itself. And we're using a modality about pattern recognition to kind of nudge it in the right direction, but that it is very self-directed. So maybe you could help better synthesize my understanding of the pattern.
Sure. Yeah, you're talking about associative learning. Things happen, things get associated, all kinds of things in the brain, the body, and the body notices the ones that are rewarding, that are reinforcing. So while neurofeedback functionally is a bit different, sitting in a chair watching a game, stop and start, it's kind of no different than a baby flopping around who manages to do a baby push-up and goes, oh my gosh, I can see 12 feet. All this information, the world is so much bigger. Holy cow, I love it. The body, the brain remembers, oh, okay, more information in that state. Let's do baby push-ups tomorrow and later on because it's cool. But the baby wasn't thinking left arm, right arm, got to do a push-up. It was just reach for the mode, reach for the activation. And there was a reinforcer, a rewarding state about, ooh, more information, yummy stuff, interesting stuff. So in the case of neurofeedback, the rewarding stimulus is just something at all. There's billions of things happening. So all we're doing is watching one little piece of the brain going, good job, good job, good job, good job, good job, again and again. And the brain starts to go, oh, okay. The big trick in neurofeedback is that we're moving the goalposts. So over the 30-minute run of the neurofeedback session, your brain's going to go through several normal to itself, typical endogenous, if you will, changes. It's going to runs of theta and beta and changes in speed and fatigue and stuff just happening. If we only pick out the 70 times that your brain had little 10-second runs of theta dropping and the beta climbing and just applauded those, of all the billions of things your brain is doing, your brain's going to notice, hey, wait a minute, why is my theta going down, being applauded? Okay. And it's going to start chasing the information flow as we ask it to have to do even more to get the same gameplay. We move the goalpost adaptively. And then 10 minutes in, 50 minutes in, your brain's a little tired and you're actually not able to make the same, you aren't fluctuating as well in that direction anymore. So we make it easier. We move the goalpost, the thresholds next to where you are. So when you fluctuate again in the right direction, the applause resumes. So we're giving a directed signal of movement. And when you have these 2 or 3 different brain waves, you might be training in a session. You might be training down some slow brain waves, training down some very fast brain waves, and training up some in the middle. So you simply measure the amount you're making, boom, 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 and put a threshold just above or just below where somebody is. And then when they move across that or stay on the right side of that, the game runs. And every so often you adjust the thresholds next to where they are so that their general tendencies of the brain moving in that direction is what the brain hears about. And then we see how you feel. So yeah, operant conditioning, involuntary instrumental conditioning specifically, but it's just low-key operant conditioning with passive feedback. Yeah.
Awesome. Well, thank you. It has been a really awesome episode for our listeners. It's been an amazing journey for me, and your team is incredible. How can if anyone's listening, what would be the best way to learn more, interact with the Peak Brain Institute?
Yeah, so we have offices popping up both in the US and a couple now overseas, but most of our clients work remotely. So you guys can come to one of the US offices where we have a special for the folks who are Neurohacker affiliated, where we have like an unlimited annual brain mapping membership, and it's usually $500, but it's half price for the Neurohacker folks. It's like a biohacker special to come in and do like maps and maps and maps and maps with all your nootropics and schedule those maps. People do, and we love it. So, get in there and learn your brain. But we also do everything fully virtually and remotely. We send out equipment. So, our socials are mostly Peak Brain LA, but it's Peak Brain Institute as the main website. So come check us out. Tell us you heard us here, and tell us what your brain goals are, and we'll help you figure out yourself perhaps a bit more and give you some control over making changes.
Well, thank you so much, Andrew, today. I've learned a tremendous amount, and I'm honestly super excited to do more work with you myself. So thank you.
Of course, Dr. Kelly, my pleasure. We'll get you back in, and we'll peek more at your EEG.
This podcast is for informational purposes only. The podcast is not intended as a substitute for professional medical advice, diagnosis, or treatment. You should not use the information on the podcast for diagnosing or treating a health problem or disease, or prescribing any medication or other treatment. Always seek the advice of your physician or other qualified health provider before taking any medication or nutritional, herbal, or homeopathic supplement, and with any questions you may have regarding a medical condition. Never disregard professional medical advice or delay in seeking it because of something you have heard on this or any other podcast. Reliance on the podcast is solely at your own risk. Information provided on the podcast does not create a doctor-patient relationship between you and any of the health professionals affiliated with our podcast. Information and statements regarding dietary supplements have not been evaluated by the Food and Drug Administration and are not intended to diagnose, treat, cure, or prevent any disease. Opinions of guests are their own, and this podcast does not endorse or accept responsibility for statements made by guests. This podcast does not make any representations or warranties about guest qualifications or credibility. Individuals on this podcast may have a direct or indirect financial interest in products or services referred to therein. If you think you have a medical problem, consult a licensed physician. This podcast is owned by Neurohacker Collective.